Okay, like this we will get the output of the word count. So once we like this, we can write the big commands in the grunt cell. So once we executed the dump or the store, then only the map reduce job will submit to the job tracker. So here if you see, we execute a lot of big scripts. Yesterday we executed a lot of big scripts. So once we executed this dump or store command, then automatically it will be submitted as a MapReduce job. So it will be either it will be map job or MapReduce job. It will be dependent on big framework will convert automatically. If we need any group by kind of operations, it will convert as MapReduce. If only it will only we are going to fetch the data, then it will convert as map only job. Framework will take care about that one. So like this we can submit big script also we can submit. So whatever the statements are there, it will execute step by step, and final result it will be stored into the this whatever path HDFS path we are specifying, it will be stored. We go through yesterday. So like this we can write the big script. So whatever these statements we needed, we can load the input data, then we can split as a words, then we can group by word, then we can count the words, and whatever the output is there, this final relation we will be stored into the final HDFS path we will store. Like this we can write the script files. Okay, same way we will go through one more example, wiki data. So how we can process the wiki data, we will see that one. I have sample data as 4 records. So in user Srini wiki1 for path in HDFS. So I'm going to split. I'm loading this file and I'm going to fetch the corresponding values. So from this, finally I'm going to which project corresponding English project, how many records are there. So like that we can analyze the data. Okay, we'll see that one. So we are going to load the sample data. So this this wiki data we are going to load. So this data we are separating, delimiter we are giving as a space, and whatever the fields are there, like this we need to specify the fields. How we are specifying the column names in the hive. So same way we will give the different fields name we will give, like page name, project name, page count, and page size. So whatever this data, these 4 fields we are loading by comma separated. So I'm going to load the wiki data. So by using space separated, and these are the 4 columns: project name, and the page count. So then we will go through other statements. So I'm going to filter the records by using only EM project, only English project records only I want. So then I'm going to filter. So this is like a where condition in Hive. So whatever the relation is there, and on previous relation, I will perform the other operations like filter, group by. So I need to perform. So then we will go through the group record. So like this, if we want, we can execute one by line, or the we can execute the as a big script also we can execute. If we want, we can apply the sorted by also we can apply. So finally, I'm going to store. Okay, before going to execute that command, we'll see. So like this, I submitted different statements in the grunt cell. So if we want to submit in grunt cell, we need to one by line, we need to submit. So this each relation will be linked, will be depend on the previous relations. So like this. So first relation is this one records. Okay, this is the first relation. So here only I'm going to load the data. So whatever the data is there, it will be in the this records relation. So we will go through this relation. What are the things is there? So here if you check the describe records, in this records we will have the this whatever the fields are there. So those fields name we will have like this. If you go through the other filter records, you can check the what are the fields or what are the data is there. So we can check by using describe. So here if you check it, so this is pointed to the filter record, also pointed to the whatever the data is there. So that is pointed to the this one. So finally, if you describe, if you see the sorted underscore result, we'll see what data it will be there, we'll see. So like this we can see the so this is the data, this data only group and the count, whatever the operations. I think here we are grouping the data by using the page name. So here we'll have the page name, comma, count will be there in the here. So these two fields will be in the sorted underscore result. So like this we'll have the like this we can see the each relation, what are the information is there. So basically first relation what we are doing is we are loading the this data to this relation. So this relation on this records relation, I'm going to filter the data by using this condition. If project name equals EN, then only the data will be pointed to this filter underscore record. Then I'm going to group by using page name. So on this grouped records, I'm going to perform some other operations like sum. Later this result I'm going to perform on the, so like this we are maintaining the relation. Temporarily this each relation data, it will be while executing the program only, temporarily this data will be stored into disk. So once the script is completed, so all data, all relations data it will be deleted. So temporarily it will be stored into a disk, and these relations also will this relation details it will be stored into memory, but data will be stored into the disk. So each relation data will temporarily it will store into disk. Once the this big script is completed, then every all relation data it will be deleted. Okay, we'll have one more command called explain. So what it will do means it will so if you give the explain and the relation name, so it will show the how this flow will be executed. So first it will sorted list, it will be depend on the internally it will depend on the group. So how it will be depend, so that flow it will be explained here. So sorted result to result, then groups, then filter records. So how it will each relation, how it will be executed. So what are the fields will involve. So all this flow will be explained, physical plan, and how the data will be fetched. So internally what are the fields are involved. So full flow we can see. MapReduce plan also we can see like this. If you give the explain, so you will get the like this, where the combined plan will be there, where the reducer plan will be there, so where the sort plan will be there. So every details will be given by the explain keyword. So if you give the explain and this relation name, so then it will give the all the all the details, how the map plan, reducer plan, how the sort, and how the full global plan, each relation how it will be depend to other relation. So all details will be dependent that one. So by using explain command, so we can see the details. So like this, we can write the each statement. Like first we load the data. So then we will, if you want, we can perform the filter operations. If you want, we can perform the group operations. Then if you want to see the details about the each relation, you can see by using describe, and also explain also. We can see the full how the particular relation, how it is going to execute it, what is the map plan, reducer plan. Those details we can see it. So once the then if you want to store, or if you want to if you want to see the what output of the each relation, either you can run as a dump, it will be display the output on the console. So instead of that, if you want to store the output to the particular hrefs directory, then we will use the store command. So I'm going to store this result into this folder, wiki underscore output. So I'm going to store the result into this path. So once you submitted dump or store, then only this all the statement will be executed as a MapReduce program, and whatever the plan we saw, so that plan will execute it. So it will submit as a MapReduce job. So same like MapReduce job, you can see the counters information. You can see how many records are there, how many records will input records and output records. MapReduce reducer input records, output records. You can see it. So like this, it will be converted as MapReduce job, and it will execute one by one statement. It will execute. I I think in job tracker, if you want, we can see the what are the relations are involved. You can see. Okay, it is completed. So once we completed, we will get the success status, and here we'll get the how many bytes written and how many records written. So I think if you observe the input, so we have the only two records with the EN matching with EN. So that's why only we got two records here. So here total records we got two only. Here we can see the what is the input and what is output also. Here we can see stored in the wiki underscore pig underscore output. So okay, I given user Srini instead of user Srini. So we'll check in that folder. Directly we can copy and paste it. Okay. So like this, whatever the fields we are trying, so like this we'll get. So like this we'll get the whatever the fields we want, we can analyze like this. Okay, this is how we can submit the each line to the pig and each statement to the pig. So like this we can whatever the data we want to analyze, we need to write the different filter and group by and the sorted and limit. If we want limit like this we can write it, and finally if we want to store, we can store it, or if we want to display the result in the console terminal, so we can use the dump command. So similar way we can write the pig scripts also, we can write it. So whatever the commands we executed in each individually, so we can execute as a script file also we can execute. So for that we can go through the this path home training pig script. Here we have the pig scripts. So we can see okay. So like this, whatever the commands we executed, so we can copy to one file and we can name it as a .pig, and we can run the, if you want to run the pig script, so we need to run the pig space, whatever the file name, pig script file name, we need to give wiki.pig. Like this, we need to execute the pig scripts. So here in pig also we have the predefined function. So like count, sum, so minimum, maximum, and whatever operations we want to perform. Substring the other operations also, if you want, we can perform. Okay, now we'll see one more example like this Wikidata. We are going to see the how we can get the access logs. How we can analyze the logs, and how we can get the difference day-wise or month-wise data. How we can get, we'll see. We saw the we practiced examples in MapReduce and Hive. related this data, how we can get the how we can process the logs, and how we can get the month-wise data and our day-wise data, hour-wise data. So similar way, how we can do in Pig, we will see. So we have data in this path, access log data we have in. So we have this data. So last classes while explaining Hive, I explained how we can process the data with the Hive, and MapReduce also we saw. So similar way, how we can process the same data with the Pig, we will see that one. So here the all the data is separated by this page. So while loading the data, I'm going to. So first I will load the data without any fields, without having any fields. First I'm going to write the statement. So I will execute all the statements at a time. So here what I'm going to do means, without specifying the field name, so I'm going to separate the data by using this space. So here I will get the this is the relation data. So on this relation, I'm going to first I'm going to get only 10 records. So that's why I'm going to limit the data. So first I will print this data, limited data, what we'll get. So I'm going to submit this relation temp underscore limited data. Then we'll go through the other relations we'll go through. So first I loaded the data without specifying the field names, and I'm going to print the first 10 records. So if you want to limit the data, we need to use the limit keyword. We will. I'm going to print only 10 records. So I'm getting only 10 records. So similar way, how we can get the so here why we got the only first record means, I think I already submitted all the records, so that's why only we got the only first record. So here if you observe, so here we loaded the data by using the space separated, and first I got only I'm trying to print all the fields with the limited data 10. So then I applied the this one first column. So here $0 means we'll get the whatever the first field is there, we'll get the that data. So that's why only while I'm printing the limited data, we got only IP address. So 10 records, we got the IP address. So instead of that, I'm going to print the all the columns with the first 10 records. I'm going to print it. So for that one, I'm changing the this relation name limited data 1, and I'm going to print. So limited data 1. So instead of printing the one first field, I'm going to print the all other fields with limiting the only 10 records. So like this, without specifying the fields also, we can load the data. So this is the output. So we got the all the fields here. If you observe, each field is separated by the comma. So this one is the each line is the tuple. So output will get like this. So we got the 10 lines. So each output, it will be one tuple. So one tuple will have the different fields. So this is the first field and this is the second field. Second and third fields are empty. So this is the fourth field. So like this we'll get the different fields. So now I'm going to see only fourth field. Then we need to call $3 means it will point to the fourth field data. Okay, I think spelling. Okay. Then I'm going to print the values in console. So limited data. So whatever the latest value in the relation, so that value only it will try to execute. Whatever the this command is there, so that command only it will be executed. So old one will be override with the new one. So now I'm going to print the fourth field values. So like this, we can fetch the values without field names also by using index also. If you want, we can fetch the values. So instead of that one, for naming conventions, if you want, we can provide we can load the data by using the field names also. We will see next example how we can load the data with the fields. So this is the fourth field, date field. So like this, we will get the whatever the field we want. We can get the data by using the this index. We will get the index. So like $0, $1, $2. It will point to the particular field index. It will point, and we can, if you want, we can fetch the data. Okay. Now I'm going to load the data instead of the without fields. I'm going to load the data with fields. So we can specify the whatever the fields we want. We can specify the field names also. We can specify same data. I'm going to load with the space separated, and I given different fields: IP, user, empty field, and log underscore date, seconds, request type, page name. So here I given different fields. So instead of getting the by using index directly, we can get the data by using the name. We can get the name. So if we will check that one, we'll get the page names. So I'm going to get the first 10 page names. So that's why I'm going to give the page underscore name. One minute, maybe syntax wrong. Okay, like this we can whatever the field we want by using field name, we'll fetch the data. So now if you want to describe this one, describe page underscore name. So we will have only one field. So if you describe that full data, if you want to see the logs underscore data relation, so all fields will be there in this relation logs underscore data. From that I am going to get the only page name. So for this relation I have the only that page name. So now I am going to limit this data. For that I am going to give limit page underscore names. Okay, now I'm going to execute this limited data. You can give any name. Now I'm going to print the first 10 pages names. So like this, whatever the operations we want to perform. So if you want to get the first 10 IPs, then we access by using the IP. So like this, if you want to get the dates, we can get the log underscore date. Like this, whatever the data if we want, we can print like this. So finally, if you want to see the data, so then we can use the dump. If you want to store, we can use the store command. Okay, this is the output. So we print only page name. So like this, we'll get the page name as each tuple will get the values. So if you have the multiple values, so we'll get the tuple as a comma separated values. We'll get the different values in each tuple. So this is how we can get the different fields data, how we can print. And if you want to see the relation, whatever the fields are there in the relation, we can see by using describe. So next, I'm going to get the, if you want to get the month or if you want to get the data, date, how we can get from that information we'll see. So now I'm going to get the IP comma month. So how we can get, we'll see that one. So here I am going to get the IP comma month from the log underscore date. So in log underscore date we will have the this information. So from this information log underscore date I'm going to get the month. So how we can get means by using this one similar way like hive, but here index will be changed. Here we need to pass the what is starting index and what is the ending index. So by this index we'll get the month, whatever the month we want, we'll get the month. We'll print this data. So like this we can get the month, and if we want the date we can get the similar way we can get the date also. So by using the some other so if you want to get the date we need to use this is the starting index and ending index for the date. So from this one we will go through the what is starting index and what is the ending index. Like that, like this month also we will go through the what is the starting index and what is the ending index. So from that we will get the whatever the, if you want to year we will get the year, if you want to month we can get the month, if you want to date we can get the date. Like this whatever the operation whatever the fields whatever the data we want, we can extract the data. So here if you observe, so once the program is executed, we'll get the IP and the whatever the month is there, so we'll get the month. So like this, if you want whatever the data we want, you will get the data. So similar way we can do it for the day also, we can do it. Similar way, if you want to get a day, you will get the day also. Instead of running this individual commands, so we can write into one script files. So month data, if you want, we can store into one output folder. If you want to store the each day output, we can. If you want to store, we can store into some other folder. So like that, whatever the data we want, we can simply store into the each relation data. We can store into the different folders. We can store. So here if you observe, we got the date. I think for all the first fields we have the same date. So that's why we got the 8 as a, for the first time record we got the day as a 8. So now I'm going to perform the count. So month and month wise count. So how many records for the each month I'm going to how many hits for the each day, each month I'm going to find. So what information I'm going to find means this information. So for each month, how many hits are there? So that information I'm going to find. How we can do means first we'll get the month field. So from that I'm going to group based on the month. So if we want to give the name, we need to give like this. We can give the name as month. Then I'm going to group by month field. Then I'm going to count the. I'm going to get each word and I'm going to count the word. So then I'm going to print the 10 months. Only 10 months information I'm going to print. Instead of printing the console, we can store this month information. If you want, we can store into any HDFS Spark by using store command also we can do it. So like this, we can get the whatever the how many hits for the each month we can calculate. So similar way we can get the each month data. So April, August, December, February, January. This is order we got the data. So like this, if you want to see the data, we can see in terminal, or if you want to store the this analyzed data, so we can store into any HDFS file. So finally, this data, this information, if you want to show as a report, we can move to the any MySQL tables by using scoop. If you want, we can move it. So you can show as a reports. If you want to show, we can show. This is the how we can analyze the data and how we can store into HDFS. So once we have the analyzed data in HDFS, later we can different ways we can use this data. So we can use this data in Hive. Again, we can, if you want, we can use, or if you want to use, if you want, we can move this data to the RDMS table. We can move it and we can use as the report. So here instead of here where we'll use this big. So if you want to use any MapReduce program, if you want to write any MapReduce program, so apart from the Hive, so we can execute as a pig scripts. So internally it will convert as a MapReduce job and it will give the whatever the data we want. So if here we will get the data as a comma separated. This data will move to the any Hive, or if we want, we can move to the other thing. So like this, we will analyze the data by using the pig. So whatever the information, whatever the data, if you want to analyze, we will analyze the data. So if you want to store, we can store it. Likewise, if you want to get the page names, page-wise result also we can perform. We will get the group by page, and page-wise count also we will get. So finally we can print the page-wise. And if you want to sort, we can sort by ascending or descending order. We can sort. If you want limit, we can limit the data. So like this, we can do the different operations. We can do group by, filter, order by, limit. So like this, we can, whatever the how we are going to analyze the data, we can write the what steps in the pig scripts, and we can execute all the steps. Okay, this is how we can analyze the data with pig. So if you want to practice, if you want to get more details and theoretically, we'll have the document called this Clojure-pig training.pdf. So I think this PDF I already shared. So we will go through this PDF. I think here we will get the more details theoretically, and for practice also we'll have more commands, more examples we'll have. So we will go through this material also. So this is how the data flow is, the pig data flow. So like this we'll write the different keywords. So finally it will do parses, checking, optimizes, plan execution. So pig tool will take care about all these things. Internally it will interact with the Hadoop data by using map or the reducer. Will filter will use the only map. If you want to count or if you want to sum, then we'll go for the reduce. So like this it will execute. Pig flow will be like this. So I think we already discussed about these things, how we are going to configure and install the pig. So directly we can go to the our VMware machine and we can execute the pig. So previously I discussed about we have the two modes, local mode, and we can reduce as a distributed mode or the MapReduce mode. So this is the, if you want to run in local mode, we won't interact with the HDFS data. We'll interact with only local data. Normal files will interact instead of the HDFS files. So for that we need to use the pig space -x space local. Directly if you want to execute as a MapReduce program, I think till now we this one pig directly you can enter the pig and we can execute. We can enter into MapReduce, or this way also we can enter into the HDFS mode. We can enter. So how we can access the pig? This also we discussed later. Previous yesterday class we discussed. So interactive mode means till now we are interacting with the grunt cell. If you want, we can interact with the grunt cell means we'll copy the statements and we can execute in the grunt shell. Instead of that one, we can run the pig script by using the pig space. Pig script we can execute. So similar way we can write the like JDBC, like we can write the Java classes also we can write and we can execute. And we can execute I think in Eclipse also I think we have plugin called pigpen. So by using that plugin also we can execute the this pig programs we can execute. These are the different ways how we can access the pig. So interactive versus means we will write the each command in the shell. Instead of that one, batch means we will write the all the commands in the pig and we will execute at a time. So these are the different options for the pig help pig version. You can check it. Go through these documents. I think you can able to practice all the commands. If you want, we can execute the HFS commands also. We can execute from the given other commands. Inside the grunt shell also, we can execute the pig scripts. This is about the. You can go through these points. You can get the more details. On pig server, how you can submit the pig commands by using the Java. We can execute from Java also, like this we can execute. So how you can load the data? This is the different storages. I think till now we discussed about pig storage. Like that we'll have the lot of storages, binary data, text loader, pig dump. So we'll have the different storages. If you want to load the data from the other data sources, if you want to load the data from the HBase or Cassandra, other databases also, we can load the data by using, we have the different storages. So by using this one, we can load the different formats data, we can load it. So this is how we can load the data by using pig storage. By using text loader also we can load the data. So these are the information about the bags. You can go through and you can check it. What is the pig tuples and bags will be there. You can go through different how you can load the data by using the different fields and defining the fields. So adding data types, how we can add the data types. So all these things we discussed. So if you want to practice, you can go through this material. These are the different data types: int, long, float. These are the I think common data types. These are the three new data types: tuple, bag, and the map. We already discussed about this one. So tuple means comma separator like this will be there. Bag will be ordered collection. This is the collection of tuples. We'll call it as a bag, and map is the key value page. So these are the different how we can load the data, how we can come. So this is the describe or the explain or the illustrate. These are the different commands. So how we can if you want to see the details about each relation, you can go through describe and also explain and also illustrate. So it will give the details about the data type, how much size. So all the details it will give. So these are the few more describe and illustrate are the other few more keywords for viewing the schema of the particular relation. So how we can dump the data? This is we already saw this one. We want to store the data to the particular directory. How we can store the data into? By using the store command, we can store the data. If you want to practice that word code example, wiki example, you can go through the hands-on experience book, and also we have the examples. I will share this file also. You can go through this thing. You can practice some access log data also if you want. You can practice. So in this material also we'll have the some keywords to practice. You can go through this material also. I think I have a question from the Ramesh. Can we directly load data into RDMS using pig load? No, no, no. We can't load data into RDMS by using pig load. So pig load means we can, whatever the input data in HDFS, we can load into as a relations. If you want to load the data as relations, then only we'll use the pig load. We can't load the data. Yes, by scoop only we can move the HDFS data to the RDMS. We can load it, and if you want to load the RDMS data to the HDFS, then we can do that also we can do by using scoop. Okay, these are the different operations we can, if you want, we can perform group, for each, and filter. These are the different operations we can perform. So go through this example, maybe you'll get more practice. So for each, generate, filter by, eliminate. If you want to eliminate the duplicates, we can use the distinct keyword. We can use distinct. So you go through this material, we'll have the brief description about what are the count and group, what we'll do. So this material will help to practice more commands. Group all, order by, limit also we can do it. Top n records, if you want to get only top n records, we need to order by descending, and we need to limit 10, then we'll get the top n records. We'll get the top n records. If you want to get the top 10 records, what are the pages visited, most visited pages, top 10 pages. If you want, I need to descending order. I need to order by descending, and I need to use the limit for getting the top 10 pages. If you want to give nested order, we will give nested also, you can give it. So like this, we'll have the different keywords. Go through this material, I think you will get the more idea about the each keyword. You will get the more idea. So instead of that, if you want to practice more keywords, we can practice. I will give those details. Go to official website apache.org. Reference manual. They will give the description about each keyword. We'll have a lot of other keywords also: co-group, cross, distinct, filter, for each. So we'll have the lot of keywords. So if you go through these keywords, you will get the description and different options. Also, they will give the neat description about the each keyword. They will give the neat examples. Also, will give description and neat example will give. So whatever the other commands apart from what we discussed, if you want to get the details about the other commands, other keywords, so you can go through this one: describe, dump, explain, and illustrate. You'll get the examples about the different things. So we already have the predefined functions. So average, contact, count, difference, maximum, minimum, sum, tokenize if you want. So like this, we'll have the different keywords. Different functions. Like this, if you want to, instead of using the predefined or already existing functions, if you want to write user-defined functions also, we can write in the pig. So how we can write in the high? Similar way we can write in the pig. So pig also will have we need to write the Java class, and we need to create the jar file. Then we can load that jar file into pig, and we need to create the function, and we need to use that function. So I will show how we can do. I will show that flow. I will show. Okay, like this we can perform file commands also, HFS commands we can perform. So these are the different storage, pig store, bin store, pig dump, text loader. These are the different store functions. So these are the other descriptions, so other keywords and the other existing functions. So if you want more details, you can go through this one. pig. Simply you can go through Google, and if you enter pig user guide, then you will go to this page. You will get this page. So here you can find the different keywords. You can find it. If you want, I will share this keyword also. This link also I will share it. This is how you can write this one. So similarly, like Hive, we need to extend one class eval function, and we need to implement one method execute. So after if you write the class and if you create the jar files, you need to register that jar file like this, and we need to define the particular function, whatever the function we needed, we need to map to the particular class, and so we need to map the particular whatever the class is there, we need to map, and that my function we can use it in this one. So how we are using the count and sum in the pig statement. So similar way we can use our user defined function. We can use in the like this we can use. So like this we can write our own write Java class by extending this method, and by implementing this execute method. We need to whatever the logic we need to implement, we need to implement in this method execute exec method, and then we need to compile and we need to package as a jar file, and after that we need to register the jar file in the grunt shell if we're going to run. So then we need to create the whatever the method whatever the function, if you want we can write the function and we can use it in the statement, pig statement we can use. This is the how if you want to write the user defined function you can write. So this is how you can use the UDF function. So mostly these are the concepts will be there in pig. So whatever the operations you want to do, so similar kind of related to that one will have the different keywords will be there. So we'll have the different keywords, and if you want to write user defined functions, we can write the user defined functions. These are the different concepts in the pig. Okay, instead of if the data is in different format instead of space separated, if you want to write the regular expressions, we can write it regular expressions also. You'll see how we can do this one. So this is how we can write the regular expressions in Hive. Similar way, we can write the same regular expression. We can parse the data by using like this. We can parse. So this is how we can load the data. So we can regular expressions we can write like this, generate, and from this regular expressions we can get the different fields. So here if you observe this one, okay, this is the example what I'm telling. So first we load the data as a line. So each line we will here I'm not going to use any pig store. Simply I'm going to get the each line as a one record, and from that record I'm going to, by using these regular expressions, I'm going to get the different fields. Instead of pig store space separated, I'm going to get the data by using like this month, data, time, host, whatever the fields we want, we can get the data. So after you got the different fields, then we can perform all the different operations, group by, aggregate, and order. We can perform limit operations. We can perform. So this is one way of if you don't have the data in particular format like space or comma separated. If you have the data in different other formats, we can get the data. So in this here we will have the data like this. Input data will be like this. So from this here we can get the data by using space separated. So if you, these are the different fields. Month is the main, date and the time, and log message is the full data. So this is the full as a log message. So if you want to get by using space, we won't get this data. So for that one we need to use some other parsing technique. So here we are using regular expression. So by using that regular expressions, we can get the data. Whatever data if you want, we can get, and we can convert as a different fields. So once we this all the things we can execute as a single quick script. We can execute all this command. So I will share this also. You can practice this example also. You can practice. Okay, this is all about pick. So how we can write the pick statement, how we can submit the pick statement in different ways, through shell, through pick script, how we can execute, how it will convert as a job, and these are the what are the we can perform different operations, load, filter, group by, order by, and if you want we can perform limit also. And if you want to display to the console, we will use the dump. If you want to store, we will use the store command. So likewise, if you want to see the information about the schema about each relation, we can use the describe, explain, or illustrate also we can use. If you want to perform any functions, we can write the already predefined functions. If we want, we can use it like this substring or minimum, maximum, count, we can use it. If you want to write the user-defined function, we can write the user-defined function by using the in Java classes. We can write the user-defined function, and we can load the jar file, and we can create our own functions. We can create. Okay, go through these examples. I will share these examples, and I will share this material also. So go through this material, and you will get more. You can practice. Okay, this is all about Pig. Tomorrow we'll continue this scope. Thank you all.